All right, today we are only going to do this pattern, side-side angle. When you end up with this pattern, you have to go through this flow chart and figure out how you're going to approach the problem. So first, we're going to decide whether the angle that we're given, and you're only given one angle, decide whether that is obtuse or acute. Let's do obtuse first. What does obtuse mean? Yeah, greater than 90. And yeah, like the big one, like it would look like this. Okay, so here's 90. This would be acute. Obtuse would be bigger. Okay. If your opposite side is bigger than the adjacent side, then you are good to go and you will just do the law of sines. I like a picture, so I'm going to draw it. It would look like this. I guess if you don't want to draw a picture, you really don't have to, but I think that it helps. There's your obtuse angle. This would be the opposite side. This would be the adjacent side. And do you see how the opposite side is bigger? It's big enough to connect to the triangle. You would just do the law of sines. Exactly like we did last class. No different. Do you guys remember how easy that was last class? Like it went well and everybody was fine. It's just like that. You would just do the law of sines. Here, I'll zoom in. All right. If the opposite side is less than or equal to the adjacent side, here's what that would look like. You would have this obtuse angle. This is adjacent. Here's what the opposite side would look like. If it's smaller than the adjacent side, what happened or failed to happen, I guess you could say. No one has a comment on that? You're just fine with that. You would go ahead and do the problem like everything's okay. It didn't connect. Like, did we get a triangle? No. All right, so you would get no solution. I worry occasionally that I could get up here and say whatever I wanted and you guys would be like, yeah, sure, okay. Do you know what I'm saying? Like, everyone, I'm glad you trust me, but you want to like think about it a little bit more. All right, so if your angle is obtuse, it's really straightforward. The opposite side is either big enough and you do the problem and it's just like last class, or it's not big enough and you just write no solution, you don't do anything else. We good so far? Okay. Your angle is acute. That means smaller than 90. And this is, again, going to split two ways. You want to kind of draw this one a little bit bigger because then that's going to split again. Same thing for the first option. If the opposite side is bigger than the adjacent side, you're just good to go. Like, just do the problem. And if you want a picture, it would look like this. Here's your angle. It's acute. And the opposite side is bigger than the adjacent side. You would just do law of sines. Just do the problem exactly like last class. You don't have any issues. You're good to go. Just do the problem. Oh, go ahead. Do you remember how I told you to always start in the bottom left and then go to the bottom right and then to the top? If you always fill it out that way, it will always work out. That's why, do you remember how I said it doesn't matter today, but it's going to matter next time? That's why I coached you to do that from the very beginning. If you always set it up that way, it will work out every time. So just do that. I've got you. I already taught you to do it, okay? All right, now if your opposite side is less than or equal to the adjacent side, if your angle is obtuse, it just won't work. It looks like this. Now, if it's acute, this is going to split three other ways. If you end up with this situation, what you do is you drop down the height and you find h. You find the height of the triangle. And then you compare that with the opposite side. So if the opposite side is smaller than the height, I will draw you a picture. Here's what it will look like. Here's your acute angle. We would drop down the height. The reason you do that is because it makes a right angle and then you can do sine, cosine, tangent if you have a right triangle. Here's the adjacent side. If your opposite side is smaller than the height, what happened or failed to happen? It didn't work. So that would be no solution. Basically, it's like if the opposite side is big enough, then you're good. And if the opposite side is not big enough, then it doesn't form a triangle and you can't get an answer. Right? Next option is that the opposite side could equal the height. Here's what that would look like, and this is kind of cool when it turns out this way. Here's your angle, here's your adjacent side. If your opposite side equals the height, then what kind of triangle did you end up with? If the opposite side is the height, if they're one and the same, what kind of triangle is that? It's a right triangle. You can just go ahead and go right back to everything that you did on your quiz. When it's a right triangle, all of that stuff comes back. You have Pythagorean theorem, you have SOHCAHTOA, like you can do all of, you don't even need law of sides. You have a right triangle, which is like really nice. So what would the last option be? We did the opposite side is smaller than the height, the opposite side equals the height. What would the last one be? Opposite side is, put the phone away. Opposite side is what? Greater than the height. This is kind of the tricky one, and I always cut out this triangle. I'm going to do my best to like put it under the projector and show you. What happens is you end up with two solutions in this one. I'm going to try and draw it as best as I can. So your first solution would look like this. Here's your adjacent side. Here's your opposite side. Here's your height. So the opposite side is bigger than the height, but here's what can happen. You can fold the triangle back on itself and end up with a second triangle. Again, I'm not real great at drawing it. I have one cut out here that I'll show you in a second, but you end up with this like really skinny little triangle. So like when you solve that one, you end up with like a really teensy tiny angle at the top. But anyway, you end up with two solutions. So you have to do the law of sines twice. Like it's more work and it's more typing in the calculator. But here's an example of what this will look like. I'll do my best to show it under the projector. If not, I can kind of like hold it up. But here's an example of what this would look like, because I'm really not that good of an artist for drawing it. But here's a situation where you would drop down the height and the opposite side would be bigger than the height. So you would get this triangle, you following me? Like this one that's right here. You could bend this back on itself, and you would also get that tiny little triangle like this one. Do you guys see what I'm saying? Like it's super tiny, like you're folding a paper airplane, like it's a really little angle. Anyway, you'll get two answers, okay? So look, there are 1, 2, 3, 4, 5, 6 ways that this can turn out. You may notice there are 6 problems on this sheet. That's because I'm gonna do one of each of them. Okay, so you can see each way that it's gonna turn out. I realize that this is tougher material. Remember, this is only for what pattern? Side-side angle. I'm not going to give you an entire test of side-side angle. I might throw a couple of them on there, but like it's not like you're going to have a whole test of these, okay? But I'm going to do one example of each of these. So go ahead and draw a triangle. I don't care what it looks like as long as it has 3 sides. We're not going to get out a protractor and measure everything. Start with the bottom left. What angle were we given here? Good. B is 74. That's going to go right there. Now go to the bottom right. Now I don't have another angle, but what other side was I given? Like I have little b. Little b is 78. That'll go there. But what's the other side that I have? A. So make this A, and then the 85 will go across from that. If you do that every time, do the bottom left, then go to the bottom right, it will work out every time. Just do that. All right, so your pattern's side-side angle for every single one of these. Like on your test, it's going to be mixed up, but do you see how it's side-side angle? Like you have 2 sides and then the angle's not in between them. Okay, this is what tells you, oh, I have to do this flow chart. So now we're going to do the analysis. Theta is obtuse or acute. You only have 2 choices. 74 degrees. Acute, good. Everyone's always like, Miss Cole, do I have to write that? Yeah, you do. We're going through the flow chart. Theta is acute, so we're over here. Now you're going to compare the opposite and the adjacent. This one's the opposite. If you want to label that, you can. This one's the adjacent. It'll always turn out that way if you do what I've showed you to do. So compare those. The opposite is what's compared to the adjacent? Less than, good. Opposite is less than adjacent. That's like, bummer, dude. The opposite side isn't big enough And if it was obtuse, you would just stop and say no solution. But in this case, we're going to drop down the height and do this comparison with the height. So drop down the height. The reason you do that is now you have a right triangle. So try to just look at this side. Here, I'll color code it. We're going to just look at this guy. We need to find the height. Would you do sine, cosine, or tangent? Here's your angle. We're trying to find the height. We have the 85 labeled. Is that sine, cosine, or tangent? It would be sine. Is it always going to be sine, Miss Cole? Yes, it will always be sine. Sine of 74 equals h over 85. Go ahead and type that in your calculator and get the height. Make sure you're in degree mode. Again, it will always be sine, every single time. You can share when you feel ready, but what did you get for the height? Did you guys get that? 81.707? Okay. And now you're going to compare the opposite side with the height. The opposite side is still 78. That didn't change. How do these compare? The opposite side is what compared to the height? Small. 78 is smaller than 81, all right? The opposite side is smaller than the height. So this is the situation that we have here. And so what do we get to conclude? No solution. I'm going to label these as well. That was question 1, just so that if you're looking back at your notes and you're like, which one of these went with which one, I'm going to label them for you. So that was question 1. Now, the other thing I get asked is, Ms. Cole, like, it came out to no solution, but like, how would that be worth credit on the test? It's actually going to be worth kind of a lot of points because you did a lot of work there. Remember, you get a point for drawing the triangle and writing the pattern. So that's 1. I would say at least 2 points for all this analysis, and then a point for, you know, your final answer. So I'd say at least 4 points for that, even though it came out to no solution, because you did a lot of work. All right, let's try another one. Draw a triangle. I don't care what it looks like, as long as it has 3 sides. Can I answer a question? Right there. Yeah, it doesn't matter what letter it's called, whatever angle you're given, put it there. So like for this one, it'll be A. We're going to put A right there, 142. So again, the triangle is not to scale because 142 is obtuse and I didn't draw it that way. All right, and then we have little a, which is 7.3. That's going to go right there. Then go to the bottom right. Now I don't have another angle, but what's the other side I was given? B. So make this B, and across from that you'll have 5.4. C goes at the top, so that's the last side. Again, the pattern is side-side angle. That's what it's going to be for every single one of these today. But again, on the test, they would be all mixed up, so you'd have to put that. And now we're going to start the analysis. Again, this pattern is what tells you, hey, I need to do that analysis. So theta is what? I kind of already said it. Ask you guys. Theta is what? Obtuse. Perfect. And then you're going to compare these. 7.3 is the opposite side. 5.4 is the adjacent. How do they compare? The opposite is what compared to the adjacent? Greater. Perfect. Opposite is greater than adjacent. That means it's big enough and we're good to go. You just do the problem. It's exactly like last time. That's this situation right here. So like if you want to label them, you don't have to, but I'm just going to do that for you. This is the situation we have in question 2. You're going to just do the problem. All right, so let's make our little scavenger hunt list. What are we missing? We want to do angles first and then sides. B and C, perfect. And then baby c, little c. Now to set up the law of sines, you need a side across from an angle. So we have to have that. Which one is that we have? A side across from an angle. A, good. So it'll be 7.3 over sine of 142 equals 5.4 over sine of B. Now again, you're going to have to listen carefully when I tell you how to type this, because setting that up is fairly easy. Like you just set up what's across from each other. typing it in is what's tough. This is what I just went over like when I was talking about the quiz. If you want the angle, you have to anti-sign. It's sign inverse. So everybody type this. I'm going to tell you exactly what buttons to hit. Hit second sign, and then you're going to cross multiply and divide. So it's still cross multiply and divide. You just have to hit second sign first before you do that. Now be aware, do you see how when you hit second sign, it starts a parenthesis? So at the end of the whole thing, you want to end the parenthesis, okay? So second sign, and then it'll be 5.4 sine of 142, and again, close the parenthesis because when you hit sign, it's going to start one. So 5.4 sine of 142 divided by 7.3, and then close the parenthesis that it started in the first place. Moment of truth. Did you get 27.092? Okay. Now we want to store that. How do I do that? How do I capture it? Good. Now I would do B for this one because we found angle B. So I would do store alpha B, enter. You can use whatever letter you want as long as you don't confuse yourself, but I'm going to do B. Store alpha B, enter. And how do we find the last angle? What do all the angles have to add up to? 180. So do 180 minus the other two. So 180 minus 142 minus alpha B. If you don't store it, when you reuse it, your final answer is not accurate enough. You have to store it. Also, it's easier because you don't have to type the whole decimal. All right, so C would be 10.907. Good, thank you. Store that as C. If you reuse an answer, you have to store it. Store alpha C, enter. Store alpha C, enter. All right, and then we're going to do law of signs one more time. Remember, how's it going to start? Since we're doing the exact same problem, 7.3 over sine of 142. Do you remember when we did that last time? You just wrote the same thing twice. Some people will just write it twice because they know they're going to need it twice. All right, equals. Now, what are we trying to find? What's the last thing we need? Little c. So c over sine of c. You're going to cross multiply and divide. So here's what you're going to type. 7.3 sine of alpha c. And it'll copy paste that for you. So 7.3 sine of C divided by sine of 142. Again, it's cross multiply and divide. So 7.3 sine of C, just hit alpha C, it'll copy paste, divide by sine of 142. I got 2.243. Let's do one more and then I'll give you a break. Just draw a triangle. I don't care what it looks like, just as long as it has 3 sides. Start with the bottom left. How am I going to label that one? Big B, 100 degrees. It's not to scale. 100 degrees would be obtuse. Across from that, little b is 60. And then you want to go down to the bottom right. Now I don't have another angle, but I do have another side that I want to go across from that. So is this one going to be A or C? And so across from that, you'll have 82. C is the one we don't have. Again, the pattern is side-side angle. They all are today because that's the only, like, that's what I'm teaching you. That's what this lesson is on, right? So this pattern is what tells you, hey, I need to do that analysis. So theta is what? Acute or obtuse? Obtuse, good. Then you compare the opposite side with the adjacent side. This is opposite, this is adjacent. So the opposite is what compared to the adjacent? Yeah, opposite is 60, adjacent is 82. So 60 is less than 82. So if your angle is obtuse and the opposite is less than the adjacent, go ahead and flip your paper over. What do we get to conclude? Obtuse, opposite is smaller. No solution. It's not going to reach. So you have this situation. This is number 3. Basically, it's if the opposite side isn't big enough, you don't create a triangle. All right, take a couple-minute break and then we'll do the other thing. All right, for number 4, go ahead and draw a triangle. What are we going to put in the bottom left? A, good. A is 43. So what goes across from that? 16, perfect. And then what goes in the bottom right? I know we don't have another angle, but look at the other side we have. What's going to go over here? B, good. And then across from that, 8. And so the other one is C. So what's the pattern, guys? Yeah, again, they all are for today, but side angle, the angle is not in between the other sides. That pattern is what triggers for you, hey, I need to do this analysis. So theta is what? Acute. Then you're going to compare the opposite and the adjacent. The opposite is 16, the adjacent is 8. So we're going to say opposite is what? Good, greater than adjacent. That means it's big enough and we're good to go. We're going to just do the problem. So flipping over here, that's this situation. If you get that the opposite side is bigger, you're just good. Like you just do the problem and don't worry about it. Now it does involve some fancy button pushing, but you just do the problem. All right, so let's list out what we're missing. We're missing angle B. What else? Angle C, good. And side C, baby C. You need a side across from an angle. So have we got that? I mean, you have to, or I'm not going to give you an undoable problem, right? It would be 16 over what? Sine of 43. And if you want to even just go ahead and write that twice, you can. I get a lot of people that'll do that. Like they'll just go ahead and write it twice because it's like, you know, you're going to need it again. You might as well. All right, so 16 over sine of 43 equals 8 over what? Sine of B, perfect. Now, because you're looking for the angle, you have to do sine inverse. So here's what you're going to type. Second sine, and then you're going to cross multiply and divide. So it's second sine, and then inside of there, 8 sine of 43 divided by 16. And you just have to close the parentheses because when you hit sine, it will start a parenthesis for you. So it's second sine and then cross multiply and divide. 8 sine of 43 divided by 16. Anyone feeling brave? What'd y'all get? Yeah, 19.937. Okay, perfect. 19.937 degrees. Store alpha B, enter. Store alpha B, enter. You have to store it to reuse it or your final answer is not going to be accurate enough. Now, how do we get angle C? Well, all the angles have to add up to what? 180. So do 180 minus 43 minus alpha B. And that will give you what's left over for C. So there's kind of no work for that one. You just subtract from 180. I got 117.062. Okay. I like confirmation. If I type it wrong and I'm a human being, I can mess stuff up, right? I need confirmation. Quick, store it. Store alpha C, enter. Store alpha C, enter. And then we're going to set up one more ratio to get that last side. So again, it starts out the exact same way. What's going to go on the other side of the equal sign this time? Perfect. C over sine of C. So you're going to cross multiply and divide. You will type 16 sine of alpha C. Again, that'll copy paste it in there for you. Divide by sine of 43. So 16 sine of alpha C, it'll put that value in there, divided by sine of 43. And this is the last one, 20.891. Anyone else got that? Okay, thank you. Draw a triangle. What goes in the bottom left? 30 degrees, C, perfect. So across from that is 4.5. What goes in the bottom right? Which angle? I know we don't have another one, but which one do we want to put there? B, good, because across from that, we're going to put 9. And so then this one we don't have is A. And so again, it's side angle. That, oh, you guys are flipping back over and looking at, that's awesome. This is what should trigger for you, hey, I need to do the analysis. All right, so theta is what? Acute, perfect. And then you compare the opposite and the adjacent. The opposite is 4.5, the adjacent is 9. So the opposite is what? Less than adjacent. That's like, bummer, dude, it's not big enough. And if the angle was obtuse, you'd just be done. You'd be like, oh, no solution, didn't make a triangle. But when it's acute, then you have to compare to the height. There's like a secondary comparison that you have to do. So go ahead and drop down the height. That creates a right triangle, which brings back Sohcahtoa and Pythagorean theorem. You get all that back when you have a right triangle. And here I'll highlight it. We're going to look just at this one. How would we find the height? Try to just look at that green triangle. Good. Is it always sine? Yes, it will always be sine. Sine of 30 equals h over 9. Go ahead and type that in and we'll find the height. This one should make you go, what did you get for your height? 4.5. What does that mean? They equal, so it just is a right triangle. So that's this situation. Again, you don't have to be labeling them. I just am, so you can look back at it, all right? So here's what I would do, and hopefully you're writing with pencil and not pen, all right? I would erase and just make it be the right triangle, just because I feel like that's easier to deal with. So this is 4.5. Here's side A, and then we can just use right triangle trig to find the stuff that we're missing, or Pythagorean theorem. Again, you get all that. It's just like your quiz. All right, so let's list out what we're missing. Weirdly, we're missing angle B, but what did that turn out to be? 90. So that's cool. Angle A, we're also missing. Well, if that's 90 and this one's 30, what's angle A going to be? 60. That's cool. So actually, it's one of the special right triangles. And then what's the last thing we're missing? Side A. Perfect. So here's your point of view. Actually, you can use either one of these. So I guess you could do cosine or you could do tangent. It really doesn't matter. What do you like better, cosine or tangent? Let's do tangent. Tangent of 30 equals what over what? Tangent is opposite over adjacent. That's your TOA. So tangent of 30 would be 4.5 over A. I know, I'm sorry. This is an A and that's a 9. I'll try and make the 9 like a whole lot taller. I know that looks stupid, but I know A's look like 9s. I used to draw my A's like this, and too many, like a typewriter A, and too many people complained that they looked like 2s. So I can't win with A. Like, Like I literally changed my handwriting because so many students complained about it. But now my A's look like 9, so like I can't win. Anyway, go ahead and type this in. 4.5 divided by tangent of 30. I got 7.794. I guess we also could have done Pythagorean theorem. If you'd prefer to do Pythagorean theorem, you could do that too. If it's a right triangle, you have so many options because you can do all that stuff. All right, last one. I want you guys to try and label the triangle on your own. Go ahead and draw it and decide what goes where. Bless you. And some of you are flipping it over already. All right, what'd you put in the bottom left? A is 30, perfect. Across from that, 28, perfect. What'd you put in the bottom right? Big B, across from that, 41. The other side and angle will be C, it's side-side angle. This, again, this pattern is what triggers for you, hey, I need to do the analysis. So theta is what? Acute. Now we're going to compare these. 28 is the opposite, 41 is the adjacent. So the opposite is what compared to the adjacent? Less than. Bummer, dude, it's not big enough. That's where it's like, oh man. And again, if the angle was obtuse, you'd just be finished. You would just say no solution, right? But when it's acute, what are we going to do? Because there's like a secondary analysis. What are we going to do? Find the height. Good. Drop down the height. We're going to look just at this triangle right here. It'll be sine of 30 equals what over what? Good. H over 41. Go ahead and type that in. We'll find the height. Oops. Typed mine wrong. What'd you get for the height? 20.5. Me too. Now you compare the opposite side with the height. 28 is still opposite. Opposite compares how to the height? Greater than. The opposite side is bigger than the height. That means it's big enough to make a triangle, and not only does it make one triangle, it actually makes 2. So we're going to get 2 answers for this one. Save the best for last. So let's list out what we're missing. We're missing angle B. We're missing what else? Angle C, good. And then little c. So here's what you want to do when you get 2 answers. And it's not actually going to be more work. It's just going to be more button pushing, which is like kind of annoying, but get over it. All right. Draw a squiggly line down here. We're going to put one set of answers on this side and one set of answers on this side. All right. I need a side across from an angle. So which one is that? A, good. 28 over sine of 30. And if you even just want to go ahead and write it twice, and I know I kind of didn't leave enough room, but 28 over sine of 30 equals 41 over sine of B. Because you are looking for the angle, what do you have to type? Inverse, good. You're going to type second sine and then cross multiply and divide. So 41 sine of 30 divided by 28. And again, just remember to close the parentheses because when you hit sine, it's going to start a parenthesis. So second sine and then 41 sine of 30 divided by 28. Moment of truth. Anyone want to share? What did you get? Oh, I hit something wrong. Oh, I hit decimal point 41 instead of just 41. Let me get rid of that. There we go. Is that what you got? 47.066. Do you see how I knew it was wrong now? Because I didn't make any sense for it to be like, what did I get? 0.419. That doesn't make any sense. All right. So this is 47.066 degrees. Hurry up, capture it before it gets away, quick. Store alpha B, enter. Now to get angle C, you're not gonna do any work like that you have to write down. All the angles add up to 180, so just do 180 minus the other two. So 180 minus 30 minus alpha B. So 102.933. Hurry, capture it quick before it gets away. Store alpha C, enter. Again, it's not more work, it's just a lot of button pushing, right? Store alpha C, enter. All right, so this last one, 28 over sine of 30, it starts the exact same way. What are we gonna have on the other side to get what we're missing? Good, C over sine of C. So cross multiply and divide. You're gonna type 28 sine of alpha C, it'll copy paste that in there for you. 28 sine of C divided by sine of 30. Again, just close parentheses when they start them. So 28 sine of C divided by sine of 30. And I got 54.579. Thank you. That's one whole triangle. That would be like this one. Now we're gonna do the one that gets folded over. You need to expect this angle up here to be really, really, really teensy tiny. Do you get what I'm saying? Like that one's gonna be really small. Again, it's just gonna be a lot more button pushing. Here's how you get the other answers. Whatever is down here, so here's the whole triangle. Whatever angle is down here, be it A, B, or C, it doesn't matter. When you fold that over, it gets folded along a straight line. What is a straight line worth? How many degrees? Good, 180. We don't have any skateboarders in here. A straight line is 180. A whole circle is 360. So 180. That makes me a little nervous. But a straight line is 180. So whatever angle is down here in the bottom right, you're just going to do 180 minus that, and that will give you the other one because you folded it along a straight line. Okay. So which one did we have in the bottom right? B. Do 180 minus alpha B, and that will give you the new alpha B. You should get a larger angle for that one because the one at the top is going to be really teensy tiny. 132.933. Okay. Store that as the new alpha B. Every time you store, you cover up what's there before. So store alpha B, enter. But Ms. Cole, we lost the old one. Yeah, but we don't need it anymore. It's dead to us now. We're on the new triangle, right? Store alpha B, enter. C is the last angle. And again, we're not looking at any of these anymore. We're done with that triangle. Just try not to even look at them. To get angle C, you do 180 minus the other two. This one is still 30. It didn't change. It's still sitting there at 30. So you do 180 minus 30 minus alpha B. This is the one that should be really, really tiny. You should get something in the teens for this, or even like single digits. Like it should be really super small. Do you get 17.066? It should be really small. Quick, capture it. What are we storing that as? C. Store alpha C, enter. And then again, you don't have to write anything else down. Do you see this right here? This last one that we did? You're going to do that again. It's just when you do alpha C, it's going to use the new alpha C. Because C is so tiny, you should get a really tiny answer for this one as well. Remember, the smallest side goes across from the smallest angle, so you should get like a little answer. Well, little in comparison to these. Like it should be smaller than these ones, right? So go ahead and do this one more time. 28 sine of C. If you've stored it, it'll input the new alpha C, and then divide by sine of 30. 16.434. And that is a good bit smaller than these ones. It should be the smallest one. So again, to recap, when you get a second triangle, did we have to do any extra writing? No, it all happened within the calculator. if you have trouble with your calculator, please see me so we can sit down next to each other and I can help you type it, because if you can't get through the button pushing, you won't be able to get any of the answers, okay?